All right, so today we're going to move on with chapter 2, section 6. And I'm taking a look at this first page and I'm going, okay, yeah, this is a linear function. Kind of know that it's a function of a. There is one called the constant. And again, if I was putting examples in all of these, I would say, oh, I actually know this equation. My y-intercept is 1, and my slope looks like it rises 1 and runs 1, 2, 3. So this would be y equals 1 plus rise of 1, 1/3 x. Yeah, buddy. I know what that is. I know what this is. This is y equals 2. All of my y's equal 2. This is straight up. This one is actually a good one that's going to come around every once in a while. It's the equation of y equals x. So I'm starting to look at a whole bunch of parent functions. Okay, a bunch of parent functions. This is the absolute value. Absolute v. It's, students would tell me that's a way to remember it. The v in value reminds that it looks like a v. Y equals x squared. Yeah. Y equals x cubed. So we could have the class stand up and I could say, okay, do y equals x, and you take your arms and you make a shape of this. And y equals x squared, and everybody stands up and makes a u. And y equals the square root of x. You just take one arm and you do a little funky thing and so on. But these are some of the more common ones. Yes, probably not the cube root function. That's one that we won't really talk much about. But down here's one last one, the reciprocal, 1 over x. And one of the things, as soon as I see this, as soon as I see 1 over x, I'm going, x cannot equal 0. Just my habit. Because I know we're not allowed to divide by 0. And again, 0 times 1 equals 0. We know that. 0 times 2 equals 0. We know that. So they have to be equal to each other. But if I'm allowed to divide by 0, I'm left with 1 equals 2, and math just went out the window. Math just went out the window. So a lot of these you need to be familiar with. And if we start talking about the parent function, square root, you have an idea of what it looks like. In fact, when it comes to this one, I'm also going, oh, wait a minute. X has to be greater than or equal to 0 for my domain. For my domain. Just like we talked about the domain down here. It's all real numbers. X cannot equal 0. That's supposed to be an R. That's just bad. Boom, 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 boom. That's better. That's better. Okay. So what are we going to talk about today? We're going to take those parent functions and we're going to move them. I like to move it. We're going to move them. And two of the ways we can move them are the vertical shift. And the vertical shift, you should, okay, vertical blinds. Sunsets on the horizon. So the vertical shift means I'm going to move it up or down. I'm going to move this whole thing up or down. Horizontal shift means I'm going to move this whole thing left or right. All right, let's see how we do these transformations. Okay, let's take a look at this first one. And I have the parent function. Why is my, is that a little better?
Yes, it is.
So I have my parent function, and my parent function is y equals the square root of x. And we're going to be doing things a tiny bit different than in here, but we're going to start with this. And if I said, all right, so here's x values. Here's my parent function. What are the values of this function? Well, you notice how I'm going to take the square. So if I take my parent function, square root of 0, 0. Square root of 1, 1. Square root of 2, I don't know. Square root of 4 is 2. Hey Siri, what's the square root of 2?
The square root of 2 is a positive real number that, when multiplied by itself, equals the number 2. Shall I continue?
Yeah.
It may be written in mathematics as 2 or 212, and is an algebraic number. Technically, it should be called the principal.
Yeah, okay, she's no help. Calculator. This calculator doesn't have square root of 2 on it. What good is my phone if I can't find the square root of 2? I'm going to my real calculator. I see square root. I have to hit second, x squared of 2 equals 1.414. And if you do enough math, some of you will actually learn that the square root of 2 is that 1.4, and you'll remember it. I'm now going to do the square root of 3 real quick. Second, square root 3, 1.732. Okay. And again, I know what this parent function looks like. If I was to write it, it looks something like that. Here's 1, there's 1. Okay. 2, 3, 4, I'd be up at 2. All right, so now I'm going to take my parent function and I'm going to add 2 after I do the square root. Okay, so this is now going to be 2, 3, 3.1414, 3.732, and 4. If I come over here and I graph this, y equals the square root of x, then plus 2, that's the last thing I do, I get something that looks like at 0, I'm at 2, at 1, I'm at 3, at 4, 2, 3, 4, I'm up at 4. So what did it do to my graph?
It's shifted.
Yeah, it shifted it up 2. Okay, this did a, so when I add on the end, it's doing a vertical shift. Up 2. So anytime I add something on the end, that's going to move me up or down. Let's take a look at this column. I'm going to take the square root of, I plug in 0, the square root of 2, I know that, 1.414. Now x is 1. This is the square root of 3, 1.732. If I plug in 2, I get the square root of 4, which is 2. If I plug in 3, I get the square root of 5. I don't know what that is right now. And if I plug in 2, I get the square root of 6. But if I start to graph these, this is y equals the square root of x plus 2. I notice that at 0, I'm already up at 2, I'm at 2. Okay. At 0, I'm at 1.4, yada, yada, yada. In fact, this guy would let me put in a couple of negative numbers. If I put in -2, I get 0. So all of a sudden, I take a look at this graph. Looks similar to my parent, except everything is shifted to the left 2. So this is left 2. So when I did it on the end, the last thing that moved me up or possibly down. If I affected the x first, right away I affected x. That's my left and right shift. I got this. I think I got this. Okay. X squared minus 2. I know what the parent function looks like. X squared. This guy says move it to the, well, that's on the very end. So this time I'm going to move it down to. So I took my parent function, which was here, and then I brought in y equals x squared minus 2. It moved the whole thing down. Up here when I had plus 2, it moved the whole thing up. This time, y equals x minus 2 squared. I'm going to tell you what happens. Here's my parent function. And this guy, y equals parentheses x minus 2 squared, affects the x right away. And if I went through and did all the points, I would see that it shifts it to the right 2 this time. Okay, so before I move on, and number 3 looks like a handful one. I don't like the way they provide only one graph. We're going to take this y equals x plus 1 squared minus 4 and see what its graph looks like. But before we go anywhere, I want to write this as a generic form. And I'm going to write it this way. Y equals x, and I'm going to write minus h squared plus k. And if we really took a look back at those 2 examples, here, I don't know if you can say it. Here, when I affected the x first, it moved it right 2. Here, when I affected the x first, it moved it left 2. So when I write it like this, whatever the h is going to be my horizontal shift. Whatever the k was, that number out on the end, that was my vertical shift. Okay. Now, the next problem is this. Y equals x plus 1 squared minus 4. Like I said, I'm going to do it instead of on one graph, the way I would expect the student to do it. I'm going to start with what is my h and what is my k. And the reason I start with h first is that's the one that's inside, and I work my way out. So first, what does h equal? Well, I have my standard form over here. H equals
1.
Be real careful.
minus 1.
Yeah,
Negative 1.
h is going to equal -1, and that was my horizontal shift. So I know my graph is going to go left 1. Okay. In this case, my k is
-4.
-4, which means, and again, this is my vertical shift, down 4. So when I'm doing these, I need to think of this generic form because this was important. Check this out, Funk Soul Brothers. If I subtracted k from both sides, I would have y minus k, and then inside of here, x minus h squared. And remember when we were talking about circles, how we had the x minus h, and we had the y minus k, and how they went together. Well, it's kind of the same deal, but for graphing purposes, we're going to add the k to both sides. All right, so now the fun begins. I identified my h, I identified my k. I have my parent function, y equals x squared. And boom, graph number 1. Graph number 2, I want to bring my h into play. That becomes x equals x plus 1 squared. And I said, this is going to shift my graph to the left one. Nicely done. The final thing is I'm going to shift my graph down 4. So I was over at 1. Now I'm going 1, 2, 3, 4. And I got my parabola that looks something like that. So the graph of y equals x plus 1 squared minus 4 is what you see there. I moved it left 1, and then I moved it down 4. Bravo, bravo. Oh, I get excited sometimes. So for me, find the H and K, then do this on several graphs. That truly shows you have an understanding of what's going on. What's going on? What's going on? Daniel, you good? Okay. I'm watching. See, I can actually read you. If you're still writing, I know to wait a little couple seconds more. And then but I can't see anybody else other than you and Nina. So, okay, cool. Nice. Good. Different function this time. Different function. Still going to use 3 graphs. Here, my generic form would be y equals the absolute value of x minus h plus k. So instead of my function, my parent function being y equals x squared, it's now the absolute value. Horizontal shift. Give me the value of h. It's 2. That's right. And in fact, since it's positive, it would be 2 to the right. To the right, to the left, to the now kick, walk it by, walk it by. Vertical shift. Looks like that's a 3. Since it's positive, I would be going up. And now a graph. Y equals the absolute value of x. Then I move it to the right. 2, 1, 2. Keep that shape. Still the same one. This is a graph of y equals the absolute value of x minus 2. Last graph. Over 2. Up 3. Same shape. That would be the graph of y equals x minus 2 plus 3. So instead of picking points and going through all that work, I can quickly graph this guy. He goes to the right 2, he goes up 3. To the left, to the left. Don't anybody get the Cupid shuffle stuck in their head now. And like I said, I'm going to go back and edit these worksheets because instead of just 1 graph, 3 graphs are really, truly showing you understand what's going on. Cool. Nice. Are we done? No. We have one more piece to this graphing. And that looks like a whole lot of words, doesn't it? Yeah. Oh boy. They have this letter A. Okay. And A is some good stuff. A is the amplitude. So I'm going to take this and we will use these, but we're going to take a look at it by way of graph, not here, but yeah, okay. Let's see what we have. Well, no, we can use this. Y equals x squared. This will work. I'm okay with this. Y equals x squared. 0, 1, 4, 9, 16. That's just bad. That's just bad. 0, 1, 4, 6, or 9, and 16. Now, if I have an amplitude, that's this number out front, the 1/4. Okay, it's what I'm multiplying by. The 4, it's what I'm multiplying by. So 1/4, I'm going to take a look at this first one. 0, oh boy, 1/4, 1, 9/4, and 4. So in pencil, I'm going to do y equals x squared. 1, 2, 3, 4. And I'm going to go, this is y equals x squared. And we're happy with that. We know that as a parent function. So now in blue, I'm going to graph 1/4 x squared. Well, that's there. At 1, I was at 1/4. Yeah. At 2, I'm now at 1. At 4, 1, 2, 3, 4, I'm at 1, 2, 3, 4. And I know that there is symmetry to this guy. At 0, 0, 1 is 1/4, at -2, and at -4. So if I'm graphing this in blue, all of a sudden, my graph got wider. I'm cutting my x squared values down. This graph got wider, slower kind of deal. And that's because my a is less than 1. And that's some of the verbiage that's up above. The amplitude is less than 1. Here, my a is greater than 1. Wonder what's going to happen here. So I'm taking a number greater than 1 and multiplying all these by 4. 0, 4, 16. Holy cow, 36. They expect miracles out of me. 64. I know I'm doing all the talking. I don't like it. Are you allowed to use different colors? Yeah. When it was less than 1, it was wider. When it's greater than 1, I have the point 0, 0. I have the point 1, 4. So at 1, 2, 3, holy smokes, I'm already up there. And this graph is going to grow faster. It's skinnier. Grows faster. Those of you that have to take trig, this is an important section, because when you roll into trig and you can do all of this, the trig is just one more step after this, but it's 3 really important building pieces.
So actually, speaking of trig, I saw that we had logarithms on some of the stuff we were doing. Are we gonna get into sine curves and stuff like that?
In trig?
No, I mean in this class, because I saw that we were doing some logarithms.
Yeah, no,
so-
we won't do any transcendental, no trig functions, no sine, cosine, or any of that. That's all.
Okay.
That's all saved for trig. Yep. All right. All right, he says. All right. I don't need to do another one. You know, yeah, that's just okay. And yeah, I don't like this page at all. I don't like this page at all. Okay, so we're skipping that page, and we're going to jump to something over here that becomes kind of important. Now, this is my function. It's not x squared. It's not some nice parent function, but it's my function. And we're going to see how negatives start to affect this. And when I come to this one, this is the important one. This is my negative out front. So my A is a negative number. My amplitude would be a negative number out front. So that says every one of the values that I have, take the x value, put it into the function, and it'll look like this, but then negate it. Negate its value when it becomes a y. So if I look at the y value at this spot, 0, 0, and I negate it, I get 0, 0. If I look at the y value for the second point, it's 1. So when I negate it, it's now negative 1. When I take a look at this next number, 1, 2, 3, positive 3, I'm now going to go 1, 2, 3 and make it negative 3. And finally, I go to 4 and I'm up at positive 1. Now I go to 4 and I make it negative 1. And if I connect the dots, ta-da! When I have a negative as part of my amplitude, it becomes flipped. It's flipped over the x-axis. I don't know how you want to write that, but it's flipped over the x-axis. Okay, this one's not as common. You won't see it very much, but I'm going to apply the function and I'm going to say negative x. So what was x is now negative x. So what was 0 is still 0. What was 1, this point, now goes to negative 1. What was 3, this point, now goes to negative 3. And finally, what was 4 now goes to negative 4. And what do we have? We have, again, symmetry. This one was rotated around the x-axis. This one is going around the y-axis. So here I affected the y. I was already done with my function. Here I affected the x, which before I even started. Cool. I think it's cool. So all that we just talked about is in all this wording. We talked about the K, moving it up and down, the H, moving it left and right, the A, how it made it skinnier or wider or even flipped it, right? When it was greater, then it was wider. When it was less than 1, it was skinny. And if it was a negative, it got flipped. We talked about the horizontal inside of here. And then finally, we talked about that reflection. Reflect over the x-axis or reflect over the y-axis. So like I said, most of the time reflect over the x-axis. Okay, good. We want to do one. We want to do a big one. A bigger one. Here's what we have. I am not going to write it on here because I want to do it on several graphs. And I'm going to start with this. My generic form is going to be something that looks like y equals a x minus h squared plus k. And that's the one we're going to use the most, the square function. The square function. This one just happens to be absolute value, but we're going to deal with it as well. We're going to look at y equals a, the absolute value of x minus h plus k. Again, it's just a function applied to it. Here's squared, here's it. Okay, so I'm going to take a look at this one. F of x equals 2, x plus 1 minus 3. Now, if I was a number, I'm gonna give you a number. You're gonna tell me what's the first thing I would do to the number. The number is 3. What's the first thing you would do to it?
Add the 1.
Add the 1, right? So the first thing we would do is take care of the h. That was the h, okay? Next is the parent function, the absolute value. That's all good. So I have 3, I added 1 is 4. The absolute value that is 4. What's the next thing that would get done? With my order of operations, what would get done next?
You multiply by 2.
Yep, I would take care of the a. That would be next. And then last but not least is I would deal with the k. So when I'm graphing these, those are the steps I'm going to follow. Just like if I was a number and I was being solved, that's how I'm going to do the graphs. What does this spell? H-A-K. What's that word? H-A-K. What's it sound like? Have fun with it. It's supposed to be silly. Nina, help me.
Hack.
Hack! Yes! They named this after our school. Hack. The order is, oh, okay, I'll stop now. All right, let's see what we can do with this. What is my H? What is my A? What is my K? H is
1.
that means you're really, really close. Remember, this is X minus H. This is X minus H. So if we have X plus 1, we need to make that X minus -1. Second chance, phone a friend. What's H?
-1.
-1, right? And that means this guy's going to be shifted left 1. Yep, yep, yep. What's my A?
2.
2. And I kind of know by now it's going to grow faster. It's going to be skinnier. K?
Okay.
Yeah, this is goofy, just like the H was. What's my K?
-3.
Yeah, -3, which means I'm going to be going down 3. I'm going down. I'm yelling timber. Sorry. So I looked at this. I looked at the generic form, and I came up with the hack. All right, let's graph this. I can graph this. Parent function, y equals the absolute value of x. 45-degree angles, we're doing all that kind of stuff. My next function, y equals, I'm going to take care of the h, x plus 1, the absolute value of x plus 1. I know it's getting shifted to the left 1. I'm pretty good at this. Next one, it's going to be skinnier. There's 1. Now, if it's going to be skinnier, that means it's going to grow faster. And we're not actually picking points and so forth. Some people do require that you pick some points just to make sure, but I'm trying to get all these concepts across right now. So this is y equals the graph of 2 times x plus 1. And yeah, I can tell that it's skinnier than that one. And my last graph, I'm now going to move it down 3. So I went over 1. I'm going down 3. And I know I want to be skinny. Yeah, I do. I want to be skinny. Left 1, skinnier, down 3. All right, I like it. I know, right? I don't like that one. Let me come up with one and I'm gonna have you try it. To be solid, we're gonna go with the y equals -1/2 x minus 1 squared plus 2. I'm going to pause it. I'm going to give you a couple of minutes to. Okay, so let's take a look at what we have. Here was my equation. I want to graph using translations. Okay. I know my parent function is y equals x squared. Good, I like that one. I wrote the generic form, y equals a, x minus h squared plus k. And the more I keep writing this, the more I'm going to make sure my h's and my k's are straight, because sometimes they can be negative and so forth. All right, first thing is h. H is 1. I'm going to move to the right one. My a is -1/2. And I know the 1/2, oh, I messed this up. It's not skinny, should actually be wider. Should be wider. When it was bigger than 1, so we had some different things going on. The negative in front also tells me I want to flip it. And then the last thing, k being 2, I'm going to move up 2.
So whenever we have negative value of a, we always flip it.
We need to flip it. Yeah, we do a reflection over the x-axis. Okay, so let's see what we have here. Y equals x squared. Hopefully y'all got that right. That's worth 1 point out of 5. To the right one, want to kind of maintain that same shape. Moved it to the right one. This is the equation with my h. Now the 1/2 is going to make it wider. Still that parabolic U shape, but I made it wider. Now I have another graph for the negative. So I'm going to come to 1, and now I'm going to flip it, keeping it wide. And last but not least, up 2. Okay. If I really wanted to, I could find some points here. Here's some points I would find. What if x is 0? What if y is 0? My intercepts, right? X is 0, I'm finding the y-intercept. Plug 0 in. 0 minus 1 is -1. Squared, I get 1. Times -1/2 is -1/2. So that's going to be -1/2 plus 2. That's going to be 1 and 1/2. Nice. Got kind of lucky there. If I plug 0 in for y, I could find my x-intercepts. And I'd have to subtract 2. So if I plug 0 in for y, subtract 2. Hey, this form's pretty easy to work with. Multiply by the reciprocal, -2. So that's now going to give me a +4. Take the square root, I get plus or minus 2, up -1, and add 1. 1 plus 2, that equals x, excuse me. 1 plus 2, x equals 3. 1 minus 2, x equals -1. So if I come back up here, look at this. Ah, perfect. Ah, perfect. Kind of, sort of, maybe. Cool. Questions? Do you want to do one more? Do you want to build a snowman? Do you want to build a snowman? I'm gonna check out the chat. And I'm gonna say, go. Do you want one more yes? Do you want one more no? And if I get, depending on my answers, we'll see if we're gonna do one more or not. One yes. Guess that's all I need, one yes. I need more paper. Nina. Give me a parent function. Remember, we had a whole bunch of them. We just did absolute value. We just did y equals x squared. Give me a parent function. Pick one. You're muted. Sorry.
X cubed.
X cubed. I can do that. So y equals. Still your problem. Give me a number.
7.
7. 7. X plus or minus.
Plus.
Minus.
I heard a plus first. Plus, give me a small number.
1/2.
Let's keep them integers. How about 2? Cubed plus or minus. Let's do plus again. Small number. 2. Y equals a x minus h cubed plus k. The more and more I do this, the more and more I'm going to get everything straight. Give me an H. Use the chat. Somebody give me an H. I know you don't like talking. You'd rather type it.
The -2.
H is -2. That is correct. That means I will be moving to the, that's horizontal left. I will be moving left 2. Give me an A.
7.
7.
7. Yeah, that means it's going to be really skinny. Give me a K.
2.
2. That means I'm going to be moving, since it's positive, and this is the vertical, I'm going to move up 2. So I have an H, I have an A, I have a K. I like to graph it. Y equals x cubed. It looks something like that. Take care of the H. Hack. The graph of y equals x plus 2 cubed. I move it to the left 2, 1, 2. Y equals 7, x plus 2 cubed. I'm still over here 2, but I'm going to be really, it goes really fast. Really fast. And finally, I take that graph, y equals 7, x plus 2 cubed, and I'm going to perform my last operation. I'm going to move it up 2. So I know I have that point right there from there. And I'm going to go slight turn there in the middle. Again, left 2 made it grow faster. You could say make it skinnier. Finally move the whole thing up 2. And really, I'm basing it on this point to show I'm moving it up 2.
So here with A, we cannot show it graphically, right?
I'm sorry, say that again.
That A, we cannot show it graphically. It just moves faster or slower, but we cannot point 7 in the graph.
Right. It would be
Yeah.
really hard to pick some points to do that. And like I said, some instructors would say, okay, if I put in -1, what's the value? Well, -1 plus 2 is 1. That cube it, I get 1, but then, so at -1, I'm up to 3, 4, 5, 6, 7. I'm up to that point.
Yes,
Yeah,
got you.
okay. Any other questions?